Okay, and share the screen. So yeah, so I'm theoretically done with everything I need to do, but I'll do my own stuff, so to speak, and start off with that. Okay, so some reminders. And Prasanna, if you're out there, I'll leave it to you. If you want to have your own review sessions with Prasanna, or Prasanna, maybe you've already emailed everybody, or you can put it in the chat. So preparation for our test is coming Friday. Okay, so we're here. I'm done with everything. Tomorrow's a holiday, no class, not just my class, no CSM classes, no office hours, no class, no nothing. Just enjoy your Veterans Day. And then Thursday, hopefully I'll open it up to questions and answers. But I've got some problems that people have asked for anyway. And so if some people ask for it, maybe you want it also, since I've already done it. So I'll be doing that today. So I may not get to any questions and answers today. Sorry about that. But the ones that I end up doing might answer some of the questions while we're at it. Okay, so next exam is Friday. You know the rules by now, usual rules. You submit all of this. Actually, I might as well mark this off because I'm done with everything now. So you submit this 70% rule. You must submit at least 70% of the homework. What do I end up doing? You know, sometimes half, but no less than 30%. So that leaves you a lot less than 70% to submit. Okay, and so as usual, I will have it ready for you by what, 12:01, 12:02. I'll send it through Canvas announcements, and then you can get started. I'll also project it over here as usual. And you can have your cheat sheet and your calculator as usual. Have your camera on with the natural background, no funny backgrounds, and mute yourselves. If you have any questions, put it through the chat. And then as usual, at 1 o'clock, I'll stop and I'll close the meeting as usual. Then you have until 1:05 to take a picture on your cell phone. Just click, 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 or scan. And then you have until 1:30 to submit the homework, although I'll accept early homework. That'll be fine also. Okay. All right, so we're here. Tomorrow's a holiday. So Thursday, for now, I'll let you have the entire period for questions and answers. And Friday's a test. Okay. All right, so let me go to doing my own stuff. Okay, a little bit more from Newton's method. Okay, I'm going to go back and show you number 7 from Newton's method. 2 over x minus x squared plus 1 equals 0. And your first guess, x1 is equal to 2. Okay, so this one I'm demonstrating for everybody, which means I'm not assuming you have the answer key. Okay, just actually grind it all out. Okay, so the function f of x is 2 over x minus x squared plus 1.
You're so.
Okay. I can rewrite it like this. Everybody please mute yourselves, and somebody out there is not muted, so we're hearing it. So 2x to the negative 1 minus x squared plus 1. F prime of x is negative 2x to the negative 2 minus 2x. And then better for algebra is to write it like this, negative 2 over x squared minus 2x. Okay, so your x1 is 2. So x2 is x1 minus function over derivative. And what do I plug in? I plug in the guess that they told me, 2. Okay, so I plug in 2 to the function that goes on top of the fraction. And the derivative is on the bottom, so I plug in 2 there. So 2 minus, and now f of 2. So I put a 2 there and there. So 2 over 2 minus 2 squared plus 1. The bottom is negative 2 over x squared, negative 2 over 2 squared, minus 2 times 2. That comes out to be 2 minus 1 minus 4 plus 1 over negative 2 over 4 is negative a half minus 4. That's negative 4 and a half, or negative 9 halves. So 2 minus a negative 2 over negative 9 halves. Okay, or that's a triple negative. It's a triple negative here, right? So negative, negative, negative. So minus 2. If you divide by 9 over 2, you multiply by 2 over 9. So negative 2 and 4/9 are negative 22 over 9. Okay, so that's my x2. Okay, I'm actually grinding this out. I'm not using the shortcut that I showed you. Okay, for some of you who don't have the answer key, it's a little bit tougher. So I'm doing this one for the benefit of you folks. Okay, so I do it again. x3 is x2, negative 22 over 9, minus same thing, but you can tell it's a lot harder to plug in negative 22 over 9, right? So function over derivative is the way it works. So this time for the function, I plug in negative 22 over 9, which is very clumsy, as you can see. So I plug in negative 22 over 9 to this thing, 2 over negative 22 over 9 minus x squared, negative 22 over 9 squared plus 1. Okay, so that's the numerator. That's f of x1. Then f prime of x1, I plug into the derivative function, which is over here. So negative 2 over negative 22 over 9 squared minus 2 times parentheses negative 22 over 9. In case you're wondering, yeah, you can show me what you have here, or if you're doing the answer key, you can type it in with answer, but show me that detail. I want to see that so I can give you partial credit. You can see I've gotten detailed everything here. Okay. So you can take my word for it or not. If I grind it out, I got negative 1.172318. It asks us to round to 6 digits to the right of decimal point. So there it is, I'm done. Negative 1.172318. Okay, and that is something everybody can do. Okay, and then the other one I was going to show you was 14, and I was going to show it to you with the shortcut. Okay, so those of you that don't have the shortcut, you're a little bit handicapped for that one. Okay, so 14, here was the function, and the interval they gave you was 3 to 4. Okay, now let me show you the wording again on that. 4.8. Okay, so here's the function. Explain how we know the given equation must have a root in a given interval. Use Newton's method to approximate the root, correct the 6 decimal places. Okay, so you're between 3 and 4. So I plugged in 3 and I plugged in 4. So here's the function. It's already set equal to 0, so that's perfect. Okay, I plugged in 3. You can take my word for it. I got 21. You see I messed up the first time. Plugged in 4, I got negative 236. Okay, so one side positive, one side negative. So there is a C, there's a number between 3 and 4 such that f of 3 is equal to 0. That's the intermediate value theorem. Okay, it's on page 122 on page 2.5. If you want to look that up again, I guess I should close it here. Okay, so intermediate value theorem. If you have a continuous function, this is a polynomial, is a continuous function. One side is positive, one side is negative. That means somewhere in between, the function is 0. All right, so what number do I pick? Well, I know it's between 3 and 4. I decided to start with 3.5. Okay, so the function is negative 2x to the 5th plus 9x to the 4th minus 7x cubed minus 11x. I need the derivative. F prime of x, negative 10x to the 4th plus 36x cubed minus 21x squared minus 11. Okay, so again, the way you do it is you first type in your original guess. So don't start typing anything in except get 3.5. So I literally would start off with just 3.5. Sorry, type in 3.5. That way 3.5 is stored in here in the answer button. Then I generate the formula. So every word that you think of as x1 or xo, it's going to be answer. So it's answer minus f of answer divided by f prime of answer. So here we go. Answer minus parentheses function divided by parentheses derivative. So take a look over here. Everywhere I see x, I type into here the answer button, A and S. And again, to save time, so I can do more stuff, I'll just tell you what the result is. So negative 2 x to the 5th. Everywhere you see x, put answer. Answer to the 5th power plus 9 times answer to the 4th minus 7 times answer cubed minus 11 times the answer, parentheses. Again, always put parentheses around the numerator and denominator. Divided by derivative by formula. So parentheses, negative 10, everywhere that says x, put answer. Answer to the 4th plus 36 answer cubed. You can't see that, that's answer cubed. Minus 21 answer squared minus 11. A lot of typing, but for those of you that have this calculator, you only have to type it once. For those of you that don't have the answer button, sorry, you have to do it every single time. Okay, it's little bit tougher. Okay, and I'll just show you, I did it before. Okay, so 3.329, blah, 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 blah. And then after that, I don't have to hit enter anymore. I just keep hitting enter, 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 enter. Okay, the calculator knows that the answer key is stored, and it just obeys the last command, which is still this. Okay, so I just keep pressing it, and you should show me this too on your calculator. Show me your decimal approximations until your final answer. Okay, I got 2 answers to match, then I know I'm done. So 3.274473. So show me this detail on the test. Show me this, and so forth. Okay. All right, so I am done with Newton's method. I think I've actually done 6 out of the 8 now, so that should be more than enough. Okay, and now I'll go back and do my own review. And some people had already asked for these, so I might as well just go back and show everybody. Okay, curve sketch 4.3, number 51. Several of you asked for that. F of x equals square root of x squared plus 1 minus x. Okay, so I'll show you the analysis for that one. It's kind of interesting. So 4.351. Okay, by the way, the domain is all real numbers. Okay. There's a fairly easy intercept when you plug in 0, 0, 1. Right, so 0, 1. There's no symmetry. There actually is an asymptote. Okay, I'll show that to you. Yeah, I'll show it to you over here. Okay. Now, when x approaches negative infinity, y approaches infinity. If I plug in negative 1,000,000, this will be a large positive. Minus a minus 1,000,000, that'll be a large positive also. Okay. So when x approaches negative infinity, y approaches infinity. But what happens when x approaches positive infinity? Okay, so when x approaches negative infinity, y approaches infinity. That's how I know the graph goes like that. Okay, but when x approaches infinity, I claim that y approaches 0. And here's how you show that. Okay, you multiply the top and bottom by the conjugate. Play that conjugate game again. Radical x squared plus 1 plus x divided by the same thing. So the top now looks like a minus b, a plus b. So it's a squared, x squared plus 1, minus b squared, x squared over that. And x squared cancels out. So I just have 1 over radical x squared plus 1 plus x. And now you can tell when x gets big, the denominator gets big, 1 over big is 0. So on this side, it goes like that. Okay, now my derivative analysis. Okay, so f prime is 1/2 x squared plus 1 to the negative half times 2x minus 1. Clean it up. These 2's cancel out. So x over radical x squared plus 1 minus 1. Second derivative. At first glance, the second derivative looks very clumsy, but it actually comes out pretty nice. Okay, so second derivative. Well, the derivative of this is 0, right? So that's out of the way. This one, bottom times the derivative of the top, which is 1, minus the top, x, times the derivative of the bottom. So the derivative of the bottom, we just did that. 1/2 x squared plus 1 to the negative half times 2x. 2 cancels that 2. All over the square of the denominator. Well, this thing squared is just x squared plus 1. This looks real bad, but it's actually not. Okay, and I'll show you why. Okay, there's that. Okay, 2 cancels that 2. I have x times x, which is x squared on top, square root of x squared plus 1 on the bottom. Okay. Now look at what happens if I multiply top and bottom by radical x squared plus 1, like so. Okay, now, the denominator is x squared plus 1 to the first power. This is x squared plus 1 to the 1/2 power. So if I put them together, I have x squared plus 1 to the 3/2. Okay. And now look at how nice the top comes out. If I take that times that, x squared plus 1. That times that, well, the square roots just cancel out. I have minus x squared. So if x squared plus 1 minus x squared, well, that's just 1. 1 over x squared plus 1 to the 3/2. Okay, and upon further investigation, this expression is always positive, right? X squared plus 1 is positive. raise it to the 3/2 is positive. 1 divided by positive is positive. Always greater than 0. So the function's always going to be concave up from -infinity to infinity. You see my final answer, it's U-shaped. That means f is concave down nowhere. Okay, and I have no inflection point. How come I have no inflection point? What happens at an inflection point? A change in concavity. Either the graph switches from concave up to concave down or vice versa. That doesn't happen here, so no inflection point. All right, set f prime equal to 0. So yeah, I don't have to bother setting this equal to 0. It isn't 0. It's always greater than 0. And how about set f prime equal to 0? So f prime way back here was that. Set that equal to 0. Add 1. Multiply both sides by radical x squared plus 1. So this cancels out. I have x equals square root of x squared plus 1. Square both sides. X squared equals x squared plus 1. That can never happen. That's impossible. And if you want more convincing of that, subtract x squared on both sides, right? And you'll say 0 equals 1. Well, how can 0 equals 1? Can't. Okay. Now, I'll still do my sign analysis, but what that essentially means is that on my number line, I don't lay down anything. The entire real number line is of the same sign. That means it's always positive, always negative, is never 0. Okay. So that means I can plug in any number that I want. Can you guess what number I would want to plug in? 0. 0 divided by that is 0. 0 minus 1, it's negative. Decreasing. So if f is decreasing from -infinity to infinity, f is increasing nowhere, so there's no max and min. So we got it. Here we go. Always decreasing, always concave up. On this side, approach 0. On this side, approach infinity. So that's the entire analysis of this one. Okay, so that's a 4.351. All right, so moving on. Let's see, 4.453 on L'Hopital's rule. Several people asked, limit as x approaches 0 from the right. Okay, the original was 1 over x minus 1 over e to the x minus 1. So you need a common denominator. So multiply this side by e to the x minus 1 over e to the x minus 1 divided by, on this side, multiply by x over x. So a common denominator is x times e to the x minus 1. This becomes e to the x minus 1 minus x. Okay, so now I just have a single fraction. So I don't want it as a difference. Let's say this is what I want. Okay, so now if I plug in 0, I have e to the 0, 1, minus 1, minus 0, that's 0. And if I plug in 0, 0 times that is 0, so it's 0 over 0. So L'Hopital's rule applies. So the derivative of the top is e to the x, nothing, minus 1. Okay, the bottom product rule. First, x times the derivative of the second. Derivative of e to the x minus 1 is e to the x. Plus second function, e to the x minus 1, times the derivative of the first, which is 1. Okay, so I have e to the x minus 1 over x e to the x plus e to the x minus 1. Again, it's 0 over 0. Plug in 0. E to the 0 is 1. 1 minus 1 is 0. 0, well, that wipes that out. Plus 1 minus 1. So again, it's 0 over 0. Do L'Hopital's rule again. Derivative of the top, e to the x. And now I know I don't have to do L'Hopital's rule anymore, right? Because if I plug in 0, I have 1. It isn't going to be 0 over 0. It's not going to be infinity over infinity. So this will be the last time I have to do it. Okay, the derivative of this product rule. First times the derivative of the second, x times e to the x, plus second, e to the x, times the derivative of the first, which is 1, plus derivative of this is e to the x. Now I just plug in 0. So e to the 0 is 1. 0 there wipes that out. E to the 0 is 1 plus another 1. So the final answer is 1/2. Okay. Okay, then Another problem that people asked for was 4.353, e to the negative x squared. Okay, so let's try that. First thing I notice is that when x approaches either plus or minus infinity, plug in a million or negative a million, this becomes 0, practically 0. I also notice this is an even function. If I replace x with negative x, I get the same thing back. So I will have y-axis symmetry. Okay, and what do you get when you plug in 0? You get 1. Okay, we'll get that a little bit later. Okay, so first derivative of e to the negative x squared is e to the negative x squared times negative 2x. Double prime, product root, first function, second function. So first, negative 2x, times the derivative of the second, derivative of e to the negative x squared, we just did it, e to the negative x squared times negative 2x, plus second function, e to the negative x squared, times the derivative of the first, which is negative 2. Factor out e to the negative x squared. Negative 2x times negative 2x is 4x squared, and then minus 2. So here we are. Okay, so set f prime equal to 0. F prime was, where'd it go? Right here, negative 2x e to negative x squared equals 0. Okay, recall that e to anything is always positive. So this thing can never equal 0, so forget about it. Negative 2x equals 0 means x is 0. 0, comma 1. Right? Sign chart. Okay. This is a fairly easy sign chart, I think. Okay. Remember, e to the negative x squared is always positive. E to anything is positive. So the sign is completely determined by negative 2x. Well, if I plug in any negative number, if I multiply by negative 2, it's positive. Plug in any positive quantity, this would be negative. So increasing, decreasing. So f is increasing from negative infinity to 0, decreasing from 0 to infinity, and I have a relative max, in fact, an absolute max at 0, 1. And how do I know it's an absolute max? All the graph does is it goes up, and then it goes down. Okay, I don't know the concavity yet, but it's going to go up and then go down. So quickly up and then down. Okay, then the second derivative analysis, set f double prime equal to 0. It's a little bit more clumsy. So the double prime was right here, 4x squared minus 2 times e to the negative x squared equals 0. Once again, e to the negative x squared cannot be 0. It's always positive. So just work on that. 4x squared minus 2 equals 0. A little bit of algebra. X squared is 2/4. Yes, that's a half. But when I take the square root, I'd rather have it like that. Plus or minus radical 2 over 2. It's about 0.7. Plug back in to the original function. Okay, it's supposed to be the square root of a half, right? So if I square it, I have e to the negative a half. Whoops, over here, e to the negative half. Okay, and e to the negative a half is about 0.6. So I have plus or minus radical 2 over 2, e to the negative half. This is about plus or minus 0.7. So I have to lay these down on a number line. Negative 0.7, positive 0.7. Okay, plug in negative 1. Negative 1 squared is 1. 1 times 4 is 4. 4 minus 2, positive. And yeah, this is already positive. I don't have to worry about this at all. It's definitely positive. Middle, 0. 0 minus 2, negative. Times the positive, negative. And then 1. 4 minus 2, positive. Okay, so concave up, concave down, concave up. Okay. And again, on the exam, whenever you have a chance to write the exact answer, like leave square roots as square roots, leave e as e, don't give it to me as 0.7 or 0.6 or whatever. Okay. So as exact answers, the function f is concave up from negative infinity to negative radical 2 over 2. See, this is the most accurate way of saying it. Union radical 2 over 2, comma infinity. And the function is concave down from negative radical 2 over 2 to positive radical 2 over 2. So my inflection points, because the concavity changed here and here, inflection points are plus or minus radical 2 over 2, e to the negative half. Okay, so I'm done. So here we go. Increases to 0, decreases after that. Increase, decrease. It's always positive. E to anything is always positive. Okay. As x approaches either positive or negative infinity, the y values approach 0. So that way, that way. It's an even function, so I have symmetry with respect to the y-axis. Okay. Inflection point, inflection point. So CU, CD, CU. So CU, concave up, concave down, concave up. Okay, so that's the way that one goes. Okay, and a side note, I don't know if any of you have had stats. Okay, some of you may have had stats. Do you recognize that graph in stats? Okay, this looks like the bell-shaped curve. Okay, this is actually not the bell-shaped curve, but it's close to it. Okay, the actual bell-shaped curve is such that the total area under the curve is 1. I know I'm going beyond what we need, but some of you maybe have had stats. The actual bell-shaped curve, the total area underneath is 1. That's not true here, but the actual bell-shaped curve is very similar to this. Okay, if you really just got to know what the exact function is, I can tell you, but you know, it's very. It actually has an e to the negative x squared, but there's other stuff also. But the bell-shaped curve in stats looks very much like that. Okay, that's just an extra thing. You didn't need to know that unless you wanted to. Okay, then some other ones that people asked for. Let's see, 4.449. Asked for that one also, and that was also part of L'Hopital's rule, I think. 4.449. Okay. Limit as x approaches 1 from the right, ln x tangent pi x over 2. Okay, and yes, I realize you only have 1 hour to do the test, and you might be saying, man, some of these problems are really, really long. I did one problem, one curve sketch took me a whole hour already. You know, I get it, I know it, and I'll try to construct a test keeping that in mind. So that's the most I can say. Okay, I'm not out to get you. That's probably the best I can say. I know you probably don't believe me. Okay, but whatever I give you has to be fair enough that, you know, I want to test you on, you know, the whole thing. I want to test you, do you know concave up? Do you know concave down? Inflection point, increasing, decreasing, you know, max, min, and all that stuff. But do it only in 1 hour, right? So I realize that, and so I'll try to construct a test so that, you know, I keep that in mind. Anyway, okay. In order to use L'Hopital's rule, I got to get a fraction. Say, how can I get a fraction? Well, there's tangent. Tangent is sine over cosine. So there we go. So I did sine pi x over 2, cosine pi x over 2. Okay, and now I claim that is 0 over 0. Let's see, if I plug in 1, ln 1 is 0, so that takes care of that. Plug in 1 here. Cosine of pi over 2 is also 0, so it is 0 over 0. So I can do L'Hopital's rule. LHR, you say, what's LHR? L'Hopital's rule. Okay, the derivative of the top is not that nice. It's a product. Okay, so first times the derivative of second, so ln x times the derivative of sine is cosine pi, think of it as pi over 2x, and then by the chain root times the derivative of the inside, which is pi over 2, plus second function, sine of pi x over 2, times the derivative of the first. So derivative of ln x is 1 over x, divided by the derivative of the bottom. Derivative of cosine is negative sine pi x over 2, times by the chain root the derivative of the inside, which is another pi over 2. Okay. Now it looks kind of messy, but it's actually not too bad when I plug in 1 from the right. Okay, ln 1 is 0. That's nice. That wipes all of this out. So I get to forget about all this stuff. Okay, just cover all that up. That's all 0. Plug in 1 here. That's 1 over 1, which is 1. Sine of pi over 2 is 1 on top. Then in the bottom, plug a 1 here. Sine of pi over 2 is 1. So I have negative pi over 2. So 1 divided by negative pi over 2 means reciprocal negative 2 over pi. So the answer is negative 2 over pi. Okay, and let's see. Was there something else? Yeah, another problem that somebody asked for was 4.529. So let me do that one. Do the whole works. 29. Y equals x minus 3x to the 1/3 power. This one right over there. Okay. And do the whole works. Okay. And before I even start, there's several things I have to talk about that. Okay. You can factor out an x to the 1/3 and make it look like this. Okay, and why do you want to do that? So I can get the extent, what happens when x approaches infinity and negative infinity. Okay. Right now, if I say what happens when x gets big, this would actually be infinity minus infinity, which we can't tell, but here you can tell. Okay. I factor out the x to the 1/3, x to the 2/3 minus 3. And if you're not convinced of that, just multiply this back out. That's x to the 1 minus 3x to the 1/3. Okay. And then treat this as cube root of x. This is cube root of x squared minus 3. Now you can tell when x gets big, this is big. This is big. Big, okay, I'm taking away 3. But if you have a super big number and you take away 3, it's still big, right? If you're a billionaire minus $3, you're still a billionaire, right? Still big. Okay, so that tells me that the limit as x approaches infinity of this function is going to be infinity. Okay, domain is all reals. Okay, I can take the cube root of any real number. Intercepts, well, I definitely have 0, 0. Okay, but to find any other x-intercepts is a little bit of work. Okay, so set 0 equal to x minus 3 cube root of x. Solve for x. Okay, so I add 3 cube root of x to both sides. Okay, and then cube both sides to get rid of the cube root. So 3 cubed is 27. So 27x equals x cubed. Subtract 27x. X cubed minus 27x is equal to 0. Factor out an x. So x equals 0, or x squared equals 27. So square root property, plus or minus the square root of 27, or plus or minus 3 radical 3. Okay. 3 radical 3 is about 5.1. So 0, 0, plus or minus 3 radical 3, 0. Those are all my intercepts. Okay, symmetry. F of negative x. This is what you always do for symmetry. Plug in f of negative x. So plug in negative x here and negative x there. It looks like this. Negative x minus 3 cube root of negative x. That's okay. You can take the cube root of a negative number. This will become a double negative after you take it out. So it's negative x plus 3 cube root of x. Factor out the negative 1. The reason why I want to do that is this is the original function, x minus 3 cube root of x. Well, once I write it like this. And that is equal to the opposite of the original. In other words, f of negative x is equal to negative f of x. I have an odd function, which means I have origin symmetry. Okay, now for asymptotes, okay, there's no vertical asymptotes because this thing's defined everywhere. And I made the argument over here, when x approaches infinity, y approaches infinity. Plug in a big number here, 50 trillion. Cube root is still big, not as big, but it's big. This is big, minus 3, it's still big, so big times big is big. So when x approaches infinity, y approaches infinity. And because I know it's an odd function, because I have origin symmetry, that automatically means when x approaches negative infinity, y approaches negative infinity. Okay, so that means there's no asymptotes. Okay. Or you could actually plug in a super big number. Plug in negative a billion. Okay, negative a billion. This is a large negative. What about there if you plug in negative a billion? You're squaring it, cube root minus v. It's a large positive. So what's a large negative times a large positive? Large negative. That's borne out in the final analysis of the graph. On this side, shoots to negative infinity. On this side, positive infinity. Okay, so now for the rest of the graph, do your derivative test. So y prime, probably best to use this, 1 minus x to the negative 2/3. Derivative of x is 1. Derivative of this is minus x to the negative 2/3, which I can write as 1 minus 1 over x to the positive 2/3. And y double prime, the derivative of this is, I forgot the 2/3, I guess. It doesn't change the answer any. Sorry, 2/3. 2/3 x to the negative 5/3. 2/3 x to the positive 5/3. All right, I already know x equals 0 is a critical number because it's undefined. Right? It's in the domain, but I'm not allowed to plug in 0 here. So critical number at the origin. Set y prime equal to 0 to see if there's any more. So 1 minus 1 over x to the 2/3 is equal to 0. 1 equals 1 over x to the 2/3. Cross multiply. X to the 2/3 equals 1. Ordinarily, you would say raise both sides to the 3/2. Okay, but since there's a square root involved, you actually need a plus or minus. So x is plus or minus 1. Negative 1 also works because negative 1 squared is 1, and then the cube root of 1 is 1, 1 over 1. So it definitely works. Okay, plug in 1 to the original function. 1 minus 3, negative 2. Therefore, by symmetry, I have negative 1 comma positive 2. Okay, do my sign chart for y prime, which is 1 minus 1 over x to the 2/3. Okay, so my critical numbers are negative 1, 0, and 1. Okay, now, these are the numbers I picked. And why did I pick these crazy numbers? Because I know I have to do a cube root. I picked numbers that come out to have nice cube roots, like negative 8, negative 1/8, positive 1/8, and 8. So that's the reason why I chose it. Okay. Now, negative 8, I can talk my way through it and see if I can convince you. Now, of course, you can use your calculator and test, but you don't really need it. I'll show you why. Okay. If you plug in negative 8 right here, what's the cube root of negative 8? Negative 2. That's the reason why I picked it. That's why I didn't pick negative 7 or something like that. Negative 2 squared is 4. So I have 1 minus 1/4 positive. This one's a little bit hard. I'll talk my way through it. You can follow it or not. But negative 1/8. The cube root of negative 1/8. Negative 1/2. Square it. 1/4. So 1/4 is on the bottom. 1 divided by 1/4. 4. 1 minus 4, negative. Same thing happens with 1/8. Okay, exact same logic. Okay, 1/8, cube root of 1/8 is 1/2. 1/2 squared is 1/4. 1 divided by 1/4, that's like 1 times 4 over 1, 4. 1 minus 4, negative. And then 8, same thing as negative 8 pretty much. Cube root of 8, 2. 2 squared, 4. 1 over 4, 1 minus 1/4, positive. Okay. Increasing, decreasing, decreasing, increasing. Okay. This must be a local max. How come? The roller coaster goes up and it goes down. Or you're walking, or it's a ride. You go up, you go down, max. How about at 0? You go down, and then you still go down. So if the roller coaster goes down, and then it keeps going down, that's neither a maximum nor a minimum. How about at x equals 1? The roller coaster goes down, then it goes up. Minimum. Okay, so intervals of increase and decrease, f is increasing from negative infinity to negative 1, union 1 to infinity. F is decreasing from negative 1 to 0, union 0 to 1. Okay. And that means negative 1 comma 2 is a maximum, 1 comma negative 2 is a minimum. And second derivative analysis, y double prime, and that's up to 2/3. It doesn't change anything actually, but sorry. 2 over 3x to the 5/3 cannot equal 0. Right? When is a fraction equal to 0? When the top is 0, but the top cannot be 0. There's a coefficient of 2/3. That doesn't change anything. I do, however, have a critical number at 0, right? Because 0 is not allowed. So I do put my sign chart at 0. Okay, this sign chart is quite easy. 2/3 x to the 5/3. If I plug in a negative, it's negative. If I plug in a positive, it's a positive, right? I mean, let's pick a nice number like negative 1. Cube root of negative 1, negative 1. Negative 1 to the 5th power, negative 1. 2 divided by negative 1, negative. And if you plug in any positive quantity, this whole thing is positive. So concave down from negative infinity to 0. Concave up from 0 to infinity. That means I do have an inflection point at 0, 0. Okay, so as soon as I talk about this, I'll be done. But I see we don't really have a whole lot of time left. So if somebody wants to send me a real quick question, I can't do an entire curve sketch, sorry. It has to be a quick question. We only have about 5 minutes left. As soon as I finish this graph, then I'm done. Okay, so let's get everything. Increasing, decreasing, increasing. Increasing, decreasing. This is meant to be a vertical tangent. How do I know it's a vertical tangent? Because the slope is undefined at x equals 0. Increasing, decreasing, increasing. Okay. Max, min. Max, min. 0, 0 is an inflection point. Okay. Concave down from negative infinity to 0. So upside down, U shape. The rest of the time, U shape. Concave up, like so. And there we go. Okay, so let me stop the share. We have 5 minutes left. There's not much time to do anything else. And Prasanna says there's a review session on Thursday. Thank you, Prasanna. So he'll let you know about that. Okay, 5 minutes left. I can't do a curve sketch. Or, yeah, I will now let you ask questions on Thursday, whatever you want. But we'll see how it goes. So anybody else want to ask anything? Last couple minutes? It can't be a curve sketch. Sorry about that. All right, maybe we'll call it a day. Okay, so enjoy your one-day weekend tomorrow, Veterans Day, no class, no office hours tomorrow. Thursday, come up with any questions you want, and then Friday's a test, all right? Okay, thanks, everybody. Have a good day. We'll see you on Thursday.